This lesson, we're going to be talking about a new derivative rule called the product rule. So this is useful for when you have two functions being multiplied together and you want to find the derivative of the product of two functions. Derivative, of course, being indicated by this d dx. That's just saying take the derivative, okay? In this case, we're deriving a product, two functions being multiplied together. So what's the rule for this? Instead of going through a proof at this moment, I'm just going to give you the rule, plain and simple. Maybe I'll attach a proof down below this video at some point in time, but for now, I'll just give you the rule. It's going to be f prime of x times g of x plus f of x times g prime of x. So what is this actually saying? So when we derive f of x times g of x, we're deriving the first one, we leave the second one alone, plus leave the first alone, derive the second one. So that's exactly what this line below here says, saying derive the first, copy paste the second, plus copy paste the first, derive the second. Does that make sense? Or at least is it clear for now? So what we're going to do is we're going to use this rule for the following example. Okay, so we're going to try to find the derivative of the function. Let's go with x plus 1 times the quantity x squared plus, x squared plus 1 times quantity x squared plus 2x plus 1. All right, so we're trying to derive this thing. It is indeed a product. These two things are being multiplied. One way is you could use the power rule after you foil the living daylights out of this thing. Nobody wants to foil. Foiling is tedious, so we're going to avoid it. We're just going to use the product rule instead, and then find the derivative accordingly. So we need to first identify a first function and a second function. The first function in this case is usually the one that comes first. Go figure. So that's going to be our first one. Our second one is, of course, the second function. So let's follow the instructions that we have above for deriving this thing. First things first, we're going to derive the first function, this purple underlined thing. And to do that, we need the power rule. So we're going to take this 2, bring it down in front, so that gives, and then subtract 1 from the exponent. So that gives us 2x to the first, or just 2x. The plus 1 vanishes when you take its derivative, because the derivative of flat line is just 0. So that is our derivative of the first function. According to the next bit of the instructions here, we just derive the first. Now we need to copy paste the second. So literally, as you see it, copy paste it, nothing changes. Okay. Then for the second part, we copy paste the first one. So it's just x squared plus 1 times the derivative of the second thing here. So we need to use the power rule on the green underlined thing. So we have this 2, bring it down in front, subtract 1 from the exponent, gives us 2x to the first, or just 2x. Then we have this 2x that we need to derive here, this second term. The derivative of that is just 2, because the slope of the line with slope 2 is 2. And then the 1, that bit derives away completely. That's just equal to 0. Just using power rule, nothing unusual here. And that's it. That's the derivative. Sure, you could foil this and get a nice nasty sum, combine like terms, but we're not going to worry about that. You've done what the problem asks you to do. So that's it. Just use the formula above and basically rip the problem to shreds. Get it done real fast and then finish up after you're done with the rule. If you did want to foil this, I'll go through that real quick. So we're going to take this 2x, we're going to foil it through here. And I'll have to do this really fast just to show you the final answer. So you have 2x cubed plus 4x squared plus 2x. And then we're going to foil the second one over here as well. So we're going to foil this, first, center, outer, last. So this gives us plus 2x cubed plus 2x squared. Okay, so that handles these two. Then we're going to add on 2x to handle that. And then we're going to handle this 1 times 2, so that's just 2. combine like terms as much as possible. So here we have a 2x to the third and a 2x to the third, so that gives us 4x to the third, because there are 4 of those. Then we have this 4x squared and a 2x squared, so that gives us 6x squared. Then we have a 2x and a 2x, so that's just 4x's. And then we have this plus 2. So now that is the fully FOILed simplified answer. Okay? So you could have stopped after you found the derivative. So if a problem ever asks you, just find the derivative, stop right here. Why do more work and possibly lose points when you don't have to? You did what it asked. Okay? So that's the first example. Again, as with all things in calculus, the algebra is 90% of the work. Let's do another example of the product rule involving trig. So we have, say, let's go with x squared times sine. Hopefully you are pretty comfortable with deriving trig functions at this point in time, but even if you're not quite there yet, it's okay. You'll still see the general pattern for how this is going to go down. So we're going to find the derivative of the product x squared and sine. So how does this work? Use the strategy above. We need to find a first function and a second function, and then we derive the first, copy paste the second, plus copy paste the first, derive the second. So that's the general strategy with all this. I'll try to leave this on the screen so we can see what we're doing as we do it. First function, x squared. Second function, sine of x. All right. So how does this work out? We're going to derive the first. So deriving the first is going to bring this 2 down in front, subtract 1 from the exponent. And this gives us 2x to the first, or just 2x. Copy paste the second. So you get sine of x here. Then you leave the first alone, and then derive the second. The derivative of sine is cosine. Done. Not much more to it than that. Could we factor out an x? Yeah, we could. Not going to do that. We did what the problem asked. We're good. Hopefully this is starting to make sense. Okay? If you need more examples than the ones we provided, there's a slew of examples down in the topics below. Check those out. Try to do a few of them yourself first before checking out the videos or the solutions. Helps you grow and helps you learn that way, by doing things rather than just watching them. Okay. Let's go through something that's also kind of important. What about products of 3 functions? That's a very valid question. So what if I wanted to say, take the derivative of f of x times g of x times h of x? What do I do when I have 3 things being multiplied? All right. Well, you might think that the rule is going to be very similar. It turns out that it is. Let's see if we can develop it just leveraging the product rule on 2 functions, because we can still do this using exactly 2 functions. We're going to let our first function be f. We're going to let our second function be this product. Because, hey, if I were ignoring that and I was just deriving the thing inside the green box, I know how to do that. I just use the rule above. So that'll be part of this. How do we derive this? Okay, let's derive the first function. The derivative of f is just f prime. Then you leave the entire second one alone. So you have g of x times h of x. Okay. Now we leave the first alone. So we have f of x. Now we need to derive the thing inside this green box. I should have done that in a green box, shouldn't I? Okay, so now we need to derive this thing inside the green box. So to do this, I have a first function and I have a second function. I'm going to derive the first one. So that gives me, oops, got to do that in blue, g prime of x. Derive the second one, leave the second one alone. Add on, you leave the first alone. and then you multiply by the derivative of the second. Just like that. Okay? All right, so continuing along, what we're going to do is now FOIL this. So this entire green box was the derivative of this lovely thing. So we've completely used the product rule. We leveraged the power of the product rule on two functions by taking this pair, and we turned that into one function, and then we ended up deriving that again using the product rule. So this problem used the product rule twice. So continuing along this train of thought, let's look at what we have here. We have f prime of x, g of x, h of x. I'm going to underline this first one, and you'll see why in a second. All right, now I'm going to take this f of x, and I'm going to FOIL it through this product. Let's distribute it, so you have f of x times g prime of x, h of x. Okay, then that was just the first one here. Now the second one. We're going to have f of x, g of x, times h prime of x. I'm going to underline the primes again. So now notice what's happening here. In the first term, we derive the first function, leave the other two alone. In the second term, we derive the second function, leave the other two alone. In the third term, we derive the third function, leave the other two alone. So that's the strategy for this. It works exactly the same way. And even if you wanted to have like 4 functions multiplied together, it would be in the first term, the first function's derived, second term, second function's derived, third term, third function's derived, fourth term, fourth function's derived. So it would work the exact same way with 4 functions. Okay? So that's the idea of this sort of situation here. So using this, let's do an example of this. Let's go with, let's use some trig here. We'll do sine of x times x, and let's do this times something else. Let's go with cosine of x. Why not? All right, so how do we derive this? I should put a little ddx in front of this. Sorry about that. We're going to derive this. So using the formula that we have above, the idea is derive the first, which is this little x that's here. So that's just 1. Leave the other two alone. So you have sine times cosine. Okay, then in the next term, leave the first alone, derive the second one. So you have cosine times cosine. Okay, and then finally, moving on to the next line here, we derive the third, leave the first two alone. So copy pasting, x sine of x, and then what's the derivative of cosine? Hopefully you remember that. That's just going to be minus sine of x. Okay? And then that's how this works out. If you wanted to simplify this, you definitely could. You can bring this negative out in front. So you have that. And then you don't need this parentheses anymore. Okay? So that's how that works out. So you just, in each term, in the first term, you derive the first. Second term, you derive the second. That's how this works. And it works the exact same way above, even in the first thing. First term, you derive the first. Second term, you derive the second one. And then you add it all together. Hopefully that makes sense. If you need more practice than this, please check out the manifold examples that are below. And there's also going to be some involving trig, some involving exponentials, and some that involves finding tangent lines, just like what we did with the power rule. So check those out and try to do as many of those as you can without help. That's my challenge to you.